welcome to the debate. Human fascination has always sort of gravitated toward these two extremes, hasn't it? The incredibly vast, the macrocosm, and then the infinitesimally small, the microcosm. And maybe our first attempt to bridge that gap, visually at least, was the Bohr model, picturing the atom as this tiny little solar system. Now, we know it's flawed scientifically, but that image, that analogy, it taps into a really deep question about pattern repetition in the universe.
It's a powerful image, definitely. But we really need to step past that picture pretty quickly. Because that model, the planet's whizzing around a star, it's probably the most famous wrong idea in popular science. The physics governing an atom are just fundamentally totally different from what holds a solar system together.
Oh, absolutely. Agreed. The literal Bohr analogy, it doesn't hold water. So our central question today isn't about tiny planets. It's about something maybe even more striking, the structural similarity we see between huge networks, specifically the cosmic web, this vast structure formed by galaxies, and the neural network inside the human brain. So does this quantitative similarity point to some fundamental repeating architecture in reality, like the old as above, so below idea? Or are these just, remarkable coincidences born from how complex systems organize themselves?
And I'll be arguing for the latter, for, let's call it, profound skepticism. Yes, the pictures look similar, strikingly so sometimes, but I think these patterns are basically predictable outcomes of universal efficiency rules. They're not proof of some shared cosmic blueprint. And that fundamental difference in the underlying physics, for me, that's a deal breaker for the deep structure idea.
And I'm taking the other side. I think the quantitative evidence, especially when you look at it through the lens of modern physics ideas like, say, the holographic principle or David Bohm's implicate order, it strongly suggests there is a shared blueprint, maybe even a self-aware one manifesting across different scales. Okay, so here's my position. What really pushes me towards this view isn't just a vague resemblance. It's the hard numbers, the structural metrics. We're past aesthetics now. We're talking about statistically identical geometry. The Vaza and Feletti study is key here. They compared the complexity, the topology, of both the cosmic web and brain networks. And the parallels they found are, they're mathematically startling. Take the ratios, for instance. Both systems have almost the exact same split, around 70% passive or inactive stuff, like dark energy in space or water and glial cells in the brain, versus 30% active information processing components, like the galaxies or the neurons.
That 70-30 figure is, it's noteworthy. I'll give you that.
Right? But wait, there's more. Even more amazing, maybe, is the connectivity. Their topological analysis found the average number of connections per node is virtually identical. In the human cortex, it's somewhere between, 4.6 and 5.4 connections per neuron. In the cosmic web, galaxy clusters average about 3.8 to 4.1 connections. Now think about that. These systems are separated by 27 orders of magnitude in size. They operate under completely different forces, gravity versus electromagnetism. Yet they converge on the same network structure, the same optimal number of links for stability and communication. That smells like a universal principle, a shared design logic, not just random chance.
I understand the appeal of those numbers, I really do. But my anchor has to be the established science, the known laws of physics. And that structural comparison, no matter how quantified, it breaks down because the way these systems operate is just completely different. On the macro scale, you've got general relativity, classical physics. Things follow predictable, deterministic paths. Planets orbit, galaxies cluster. But down at the micro level, you're in the realm of quantum mechanics. Particles like electrons, they don't orbit in that sense. They exist as probability clouds. The whole system runs on statistical likelihoods, not Newtonian clockwork. So this fundamental difference in how they work, deterministic versus probabilistic, it just overrides any network resemblance you find higher up. It's like having two structures that look similar from afar, but one's built with Lego and the other with, I don't know, smoke rings. They're fundamentally incompatible materials.
That's a fair point about the operational physics. But I think maybe it slightly misses the shift in focus. We've moved beyond comparing objects, sun, planet versus nucleus electron, to comparing the networks, the distribution patterns. So, my strongest argument, my round one point, really doubles down on the quantitative analysis of how matter and information are distributed, because this shows the structural equivalence goes much deeper than just looking alike. Let's zoom in on the tool they used: power spectrum analysis. Okay, this is a standard, pretty complex mathematical technique from cosmology. It's used to measure how density varies, how it fluctuates across vast regions of space. It doesn't care what the stuff is, light, dark matter, galaxies. It just measures the pattern of its distribution. So what Vaza and Feletti did was apply this exact same cosmological tool to high-res scans of the human cerebellum. And they found that the way matter, or information in the brain's case, is distributed, how it fluctuates from point to point, it follows the same mathematical pattern as the distribution of matter in the cosmic web. This isn't just saying they look similar. This is saying they are statistically structurally congruent according to the same measuring stick, despite that insane 27 order of magnitude difference in scale. That, for me, lifts it out of analogy and into quantified equivalence.
Okay, I acknowledge the rigor of using power spectrum analysis. It does move beyond just eyeballing it, but we still have to confront the original sin of this whole line of thinking, the absolute failure of the atom as solar system model. Its collapse tells us we need to be extremely skeptical. Why did it fail? Because basic physics, Maxwell's electrodynamics, dictates that an orbiting electron, being an accelerated charge, must radiate energy continuously. And losing energy means it would spiral into the nucleus in like a fraction of a second. Boom, no stable atoms. The very fact that atoms are stable proves they don't follow classical rules. They are quantum systems governed by uncertainty. They fundamentally lack the precise position and momentum needed to orbit like a planet. This deep, foundational incompatibility forces us, I think, to view any large-scale similarities as complex coincidences, however intriguing they might be.
Point taken on Maxwell. The atom is definitely not a tiny solar system in terms of forces and mechanics, full stop. But let me push back on your premise there. You're saying fundamentally different laws must produce fundamentally different structures. Okay, but if these two systems, brain and cosmos, evolved under totally different physical rules, gravity versus quantum electrodynamics, why then did they converge on that nearly identical 70-30 split between passive and active components, dark energy and water, galaxies and neurons? Shouldn't wildly different physics lead to, wildly different optimal structures, or at least structures optimized for very different levels of connectivity, not this 4 or 5 links per node similarity?
That's the million-dollar question, isn't it? And it really gets to the heart of our disagreement. My answer is, they converge not because of a shared blueprint, but because of universal constraints related to efficiency. It's basically convergent evolution on a cosmic scale. Think about it. Any large, stable network designed to efficiently process and move information, or in the case of the cosmos, to efficiently structure mass through gravity, it's likely going to face similar optimization challenges. How do you maximize connections for communication or structure formation while minimizing the cost, whether that's energy expenditure in the brain or, say, gravitational energy and stability in the cosmic web? It turns out that a highly porous structure with relatively sparse but effective connections, around 4 or 5 per node, is just a really good, stable, resource-efficient solution for building complex, self-organizing networks. It might be the mathematically optimal solution that nature finds independently, regardless of whether it's using neurons or galaxies. Okay, my turn for a question. You're putting a lot of weight on these observed patterns being, ontologically significant. But we know the human brain is essentially a pattern-finding machine. It's evolved to see connections, sometimes where there aren't any. That's apophenia. It's a well-documented cognitive bias. So, how can you be absolutely certain that these structural similarities aren't just a grand-scale case of statistical apophenia, where universal efficiency laws happen to sculpt two networks that look similar in certain mathematical ways?
And our pattern-hungry brains jump to the conclusion that there must be a deeper, meaningful connection, a shared blueprint, when maybe there isn't one.
That's a fair challenge, the risk of seeing patterns everywhere. But I think the difference here is the methodology. Apophenia is usually about finding subjective meaning in randomness, like seeing shapes in clouds. That's pareidolia, a related thing. What Vaza and Feletti did wasn't subjective. They didn't just look at images and say, gosh, that looks like neurons. They applied spectral density analysis, a hard objective mathematical tool from cosmology designed to quantify fluctuations and correlations. When that tool, applied to brain scan data, spits out results that are mathematically congruent with the cosmic web data, well, the similarity isn't just in our perception anymore. It's in the quantifiable statistical properties of the data itself. That, I believe, moves it beyond psychological bias into the realm of objective, measured structural equivalence. And to build on that, look, I'll concede the trade-off. Neither the brain nor the cosmic web is a perfect textbook mathematical fractal. They aren't infinitely self-similar at all scales, but they are undeniably powerful examples of complex, self-organized structures. And the fact that they converge on similar organizational principles, despite their vast differences, really resonates with concepts like David Bohm's implicate order. Bohm proposed this idea of a deeper, underlying, undivided reality, the implicate order, from which our everyday observed reality, the explicate order, sort of unfolds. You could argue that the brain and the cosmos, with these statistically identical network patterns, are just two different, massive unfoldings originating from the same hidden implicate blueprint.
See, I'd frame that conclusion very differently. I accept the mathematical rigor, the spectral analysis shows the pattern similarity is real, it's measurable. But my explanation remains rooted in convergent self-organization, driven by basic principles like thermodynamics and stability. That ancient idea, the microcosm mirroring the macrocosm, is philosophically compelling? Absolutely. But I think modern science demands we stick to known physics and Occam's razor, the simplest explanation. So for me, this is an explicate order coincidence, a surface pattern similarity achieved through different physical pathways. We should hold off on invoking speculative hidden layers like Bohm's implicate order until we have some actual testable physics linking quantum mechanics and general relativity. It's about prioritizing known science and avoiding cognitive biases over potentially appealing but ultimately unfalsifiable metaphysics.
Okay, but let's push the implications. If we do take the deep structural similarity seriously, where does it lead philosophically? It forces us to at least consider something like panpsychism. If the cosmic web has the statistical structure of a thinking network, perhaps it shares the function of one too. What if consciousness isn't just something that pops out of complex brains, but is a fundamental property of matter itself? Then, the entire universe, structured as it is, could be a conscious entity. The cosmic web might be literally organizing the tiny proto-conscious flickers of its constituent particles into one vast, overarching macro-phenomenal experience. This would actually lend some scientific weight to Carl Sagan's wonderful speculation that maybe our entire Big Bang universe is just, a momentary event, like a chemical reaction, inside some vastly larger entity repeating this network hierarchy potentially forever.
Function, given the radically different physics involved? For me, the scientific rejection of that literal nesting, the atom as solar system idea, carries its own profound existential weight, and we shouldn't gloss over it. Neil deGrasse Tyson puts it bluntly, we're small, cosmically insignificant in terms of matter and scale. Our significance, our wonder, doesn't come from being a tiny replica of something bigger. That's just the old, comforting analogy failing again. The real miracle, something Einstein marveled at, is that the universe is comprehensible to us at all. That this small, wet, chemically driven brain, governed by quantum weirdness, can actually grasp the laws governing 13.8 billion years of cosmic evolution across scales spanning, those 27 orders of magnitude. That intellectual reach, that comprehension bridging the micro and macro is the true testament to our consciousness, not some supposed structural identity with the cosmos itself.
Emphasizing our comprehension of the universe is a powerful point. It is pretty amazing. Okay, so let's try to synthesize. We started asking, is the universe like an atom? And the literal answer, based on physics like Maxwell's quantum mechanics, it's a clear no. But the discussion definitely highlights something more nuanced.
Yeah, I think so. We found this really intriguing structural equivalence in the networking aspects, the 70-30 ratio, the node connectivity, the power spectrum results. But alongside that, we have this fundamental incompatibility in the actual physical forces and rules governing how these systems operate moment to moment.
Right. So, if your priority lies with the quantitative convergence, the sheer mathematical parallels, and maybe the philosophical echoes of ancient wisdom ideas like Hermeticism or Panpsychism, the potential for a unified, layered reality, then the structural evidence probably points you towards seeing a layered or fractal reality.
But if you prioritize sticking firmly to the known laws of physics, that unbridgeable gap, for now, between quantum mechanics and general relativity, and if you're very cautious about cognitive biases like apophenia, wanting the most straightforward explanation, then the evidence points strongly towards convergent self-organization. The patterns are real, but they're likely just elegant solutions to universal efficiency problems, emerging independently. Fascinating coincidences, perhaps, but not evidence of a deeper, shared identity.
Ultimately, maybe the point is we're not truly separate from the universe anyway. We're consciousness that arose within it. Matter looking back at the stars that created it, finally beginning perhaps to understand its own staggering complexity on all scales.
And maybe the greatest miracle isn't finding our own reflection in the cosmos, but simply that these small minds, here on this one planet, develop the capacity to understand the universal laws that stretch across billions of light years. That comprehension itself, that's probably wonder enough.
End of debate, not the discussion. Comment your stance below.